Hello everyone, welcome back to your own YouTube channel Sciencescape Fun Day. We are going to studying about intrinsic semiconductors today on the page number 472. Previous part we have completed, so if you have not yet seen the videos, please check them. So let's start with the topic. Now it says that if we shall take the most common case of germanium and silicon, whose latest structure is shown in figure 4.3. So this is the structure of silicon, germanium or carbon, you can also say. There are the covalent bonds. Okay. So what it says next is the structure is resemble diamond. Yes, we can say it. And you can see each atom is surrounded by 4 electrons. Let it be this only. 1, 2, 3, 4. Okay. Similarly, this is 1, 2, 3, 4. This 1, 2, 3, 4 or this one. Okay. So yes, it is surrounded by 4 neighbors, and silicon and germanium have 4 valence electrons. So they share the one of the 4 valence electron with each 4 of neighbors. For example, you can say silicon has 4 valence electrons. So these are the another atoms. One silicon atom, another atoms are also available here who have their 4 empty one. So the silicon or germanium or carbon, you can say, share their one of the 4 valence electron with each other, and this sharing is known as covalent bond, or you simply say just a valence bond. Fine. And these 2 shared electrons can assume to be shuttled back and forth between the associated atoms, holding these together strongly. This is not so important. So figure 14.4 on the next page will show you 2-dimensional representation of silicon, which I have shown you. Similar structure is there. We can say that in situation will arise at the low temperature. Okay, when the temperature increases from the low temperature, when the temperature will arise, the temperature will increase, thermal energy will be more, and as the more available energy is there, some of the electrons may break, become free, and start conduction. So thermal energy effectively ionizes few atoms in the lattice and creates a vacancy. So this neighborhood with free electrons has come out, leave a vacancy with an effective charge, and this vacancy with a positive effective electronic charge is called hole. Earlier there was electron with charge, but if it has leave its place, it had created the vacancy here. This empty one is hole. So this hole will behave as an apparent free particles. What is a hole? It is an apparent free particle with effective positive charge. You have learned this formula. In the intrinsic semiconductor, number of electron are number of equal to hole, and Ni, which is intrinsic carrier concentration. So Ne will be equals to Nh will be equals to Ni, and the semiconductor have unique property, means apart from the electrons, the holes can also move. So in this figure you can see that, let it be silicon or germanium, it has its 4 valence electrons, which are further, it has shared its 1 electron, another and another one. It has shown like 2, we have drawn like this 1. So this was completely done. Now a hole is created. Let us see in this figure. 1 electron has created the vacancy here. It has a hole. So the electron from the covalent bond, side 1, side 2. So electron from this side 2 can jump to side 1 to complete its vacancy. But here again here electron will come, but here hole will create. So electron, if originally set free, is not involved in the process of hole motion. So the free electron can move completely independently as the conduction electron and give rise to electron current. अगर ये इधर उधर होगा, इनकी मूवमेंट होगी, अगर मूवमेंट होगी तो कंडक्शन होगी, कंडक्शन होगी तो करंट भी आएगा इलेक्ट्रिक फील्ड लगने पे. और जो मोशन है होल्स का एक कन्वीनियंट मेथड है बाउंड इलेक्ट्रॉन्स को मूव करवाने का जब एम्प्टी बॉन्ड होता है क्रिस्टल में. और इलेक्ट्रिक फील्ड के एक्शन के अंदर जो होल है वो नेगेटिव पोटेंशियल की तरफ मूव करता है. सो अंडर द एक्शन ऑफ इलेक्ट्रिक फील्ड द होल्स मूव टुवर्ड द नेगेटिव पोटेंशियल विच विल जनरेट द होल करंट. टोटल करंट इज I electron and I hole means sum of the electron current and sum of the hole current. So it is noted that apart from the process of generation of the conduction electrons and holes, a simultaneous process of recombination occurs, which the electron recombine with the holes, and at the equilibrium the rate of generation is equal to rate of recombination. The recombination occurs due to electron colliding with the hole. So what is here is first generation. Electron go from here on heating, hole is created. So generation of hole done. The second step is recombination, means hole electron, this will go into it and it will form the electron. So hole with electron again on the recombination from the charge carrier. So total at equilibrium rate of the generation is equal to rate of the recombination. So again next is intrinsic semiconductor. You can see at T equals to 0 Kelvin. If the temperature is equals to 0 Kelvin, it will behave as an insulator, and if temperature is greater than 0 Kelvin, thermal generated electrons, you can see electrons move from valence to the conduction band, they will conduct. So this will be the conductor semiconductor intrinsic one, because at 3 temperature greater than 0 Kelvin, it has excited some electron from the valence to conduction band, and thermally excited electrons at T greater than 0 Kelvin partially occupy the conduction band. कुछ partially इस conduction band में आ गए हैं, अगर मैं हीट दूंगी वापस भी आ जाएंगे. तो इन्होंने खुद चले गए, बट यहाँ पे क्या क्रिएट कर गए, होल्स. तो इक्वेशन है CSI और GE में सबका लेटेस्ट स्ट्रक्चर सेम है, बट कार्बन इंसुलेटर और सिलिकॉन जर्मेनियम इंट्रिंसिक सेमीकंडक्टर क्यों है? बिकॉज जो कार्बन है सेकंड, सिलिकॉन थर्ड और जर्मेनियम फोर्थ ऑर्बिट में लाई करता है. तो जो आयनाइजेशन एनर्जी है वो जर्मेनियम के लिए सबसे कम, फिर सिलिकॉन और सबसे ज़्यादा है कार्बन के लिए. सो द ऑर्डर इज it has the greatest one, then the silicon, and least for germanium. So the number of, if the ionization energy order is this, the number of free electron order will be also this. Okay, see germanium will having the highest one. The order is like this. This is the order of free electrons. Germanium will have more, silicon have also more, but carbon will have least. So as the carbon do not have free electrons for conduction, it do not conduct, therefore it behave as an insulator.